So, okay, so we are going to continue on in Module 3, which is Chapter 3 in our textbook. And the next section that we're going to be looking at, or the next sections we're going to be looking at, are going to be in regard to vector equations. We started off this module looking at vector additions, which are familiar to us from previous classes and such. Vector subtraction, I think, might have been a little bit newer concept for most of us, but we found out how to work with that. And then now we're going to be looking at vector equations. So a vector equation is really in that same format that we've been looking at. In the previous sections that we've looked at here, we've usually been trying to find the result of adding or subtracting vectors, okay? Now what you'll notice is we are going to have a vector equation with multiple vectors on both sides of that equal sign, okay? And really what we're going to end up seeing is we're going to have to solve for some unknown variables, okay? Now, when we have traditional algebra, we can only handle one unknown variable to be able to solve, right? If we have multiples, we have to have like two equations with the same two unknowns, and then we can use like substitution to solve. But when we only have one equation and we only have algebra that we're dealing with, we can only have one unknown. But when we have vector equations, we can actually have two unknowns. But the rule is that if we have two unknowns, those two unknowns need to be separated by the equal sign, meaning I can have no more than one unknown on one side of my equal sign and no more than one unknown on the other side of the equal sign. The other thing that applies here are the standard rearrangement rules of equations in algebra also hold true here. So if we look at the top equation, for instance, it says vector A plus vector B minus vector C is equal to D. You'll notice that there's the minus C here. Now, what's nice in working with vectors is when we can work with all positive ones, right? Because then we can add them tip to tail, and it's a little bit easier. We don't have to think about that negative. And not that it's hard, but it's always nice to just always work with positive values. So it's not uncommon that if you want to, you can eliminate the negative C here by simply sending it to the other side of the equation on the right-hand side, and you'll notice that it then becomes a positive C on the other side. And then, like I said, I think it's just a little bit easier and more consistent to just handle all positives rather than dealing with negatives. So know that we're going to be seeing rearrangements so that we can eliminate some negatives as well. So there's just a note down here when we cross the equal sign and we arrange our vectors on one side and the other, every time we cross that equal sign, we need to start back at the origin. So for instance, if I exhaust arranging my vectors A and B here on the left-hand side, and when I cross the equal sign, the equal sign, that means that D's tail has to be positioned at the intersection of that origin again. Okay, so you start back there whenever you cross the equal sign. So let's take a look at a couple of examples. These are the last two examples in our practice problems here. Once we have these two done, you'll be all set with practice problems, and you'll be ready to finish up the assignment 3 problems that we have assigned as well. So if you want to follow along with me, we're going to be going to page 63 in our book, which is right here, page 63. And we are going to be looking at example 316. Okay, example 316. So the vector equation that they're giving us is vector A plus B plus C is equal to D plus E. So first of all, when I look at this vector equation, the good thing is I have all positives, okay? Now, the next thing we want to do is we want to look at what we want to do here. So in the instructions, it tells us that we want to graphically determine just the magnitudes of vectors A and E. So notice it's not saying find the resultant R, find the resultant J. It's saying, okay, we've got an equation here. We don't really have any unknowns, fully unknowns on either side, but there are two vectors here, A and E, that look a little different than what we're used to. Okay. So you'll notice here B, normal vector, and it has a solid line. It's 100 inches per second squared, and it's going to be moving up and to the right at that 30-degree angle from horizontal. C is a vertical vector going straight up, 124 inches per second squared. And then D, same thing, 120 inches per second squared, but this one's going down and to the right at that 60-degree angle. So each one of these vectors are fully defined, meaning each one of these have both magnitude, and that's going to be their inches per second squared, and direction, which is identified by an angle and the arrowhead. Okay, so fully defined for each one of these. As we look at A and E, though, you're going to notice that we have dashed lines, okay? We have two arrowheads on each one of those, okay, depending on the direction. And basically what that's saying to us is we know what the direction is. So A is going to be along a horizontal line. E is going to be along a vertical line, but we don't know each one of these magnitudes, okay? So that's what they're saying in here. Determine the magnitudes of A and E. So how long are those going to be? And we're going to do it graphically, so we're going to be doing these in AutoCAD. Now, as we look here, you're going to notice that our two unknown variables are A and E. And if we look at where they're at on our equation, you'll notice that A is on the left-hand side of the equal sign and E is on the right-hand side of the equal sign. That's a good thing, okay? Because remember, as I said earlier, we can have two unknowns in a vector equation. So magnitude is unknown for A and magnitude is unknown for E. Two is okay. That's the max we can have. But we have to be sure that they are separated by the equal sign, which they are. A is on the left-hand side and E is on the right-hand side, okay? So let's go ahead and draw each one of these vectors, okay, including A and E. I'm going to put A and E on my Object 2 layer just because those are going to be the ones I'm going to be solving for. Yes, they're not resultants, but they are going to be something that I'll be measuring to get each one of the magnitudes. So we're going to draw them just as we see here. So I'm going to go over to AutoCAD, and I already have pulled up my Kinematics start file, okay? And what I'm going to do is I am going to go ahead and put my vectors in place, and I'll have you guys do that very same thing. So I'm not going to talk through this. I'm going to be doing it in the background here as well. I'm pretty confident that you guys can do the same. But if you have any questions along the way, let me know. You can, don't forget to go ahead and save as example 316. Okay, it looks like in the room, most of us are pretty close to being set for our next step. Okay. So once we have our, now go back here. Once we have our vectors in place, let's look at how we're going to lay this out. So right now they gave us the equation up here. Now we know that we can add vectors in any order and still get the same net effect. Okay, so no matter what order that we do these in, except that we have to separate our unknowns on either side of that equal sign, we can get the very same answer. So when we look at our unknowns, what you want to strategically do is you want to position them on whatever side they're on, which right now the A is on the left and the E is on the right. You want to position them at the end of the string of vectors, okay? And the reason being is that when we add our vectors together, if we start with putting A as our first vector here in the order that we see it as the original equation, we wouldn't know where to place the tail of B because there is no endpoint defined for the magnitude of A, right? Okay, so it would be like, okay, now what do I do? So what we need to do is we need to put that at the end of the left-hand side of the equation. So you'll notice that they rewrote that equation. So they're going to start with B plus C, and then A is the one that has the unknown magnitude. It's at the end of the trail on the left-hand side. Then you'll notice equal to D, which is fully defined, but then E is at the end here as well. So when we do our problems in AutoCAD, we do have to define our equation. So notice that here, the equation that we have, I am doing it in the order that they have here. So B plus vectorially C plus vectorially A is equal to D plus E. Okay, so this is going to be the order that you have to write it, and then we're now going to add in this order as well. Okay, so once we have our equation there, then the next thing we're going to do is we have to identify our origin. So I'm going to do it a little bit down here. All we have to do is make crosshairs, right? So that we know exactly where we're starting. It's important to put the origin. If I don't see an origin, it's going to be points off. That origin identifies our equal sign in our equation is really what it does, okay? So since our equation says we're going to put B first, so we are going to move vector B. We're going to take its tail and we're going to put it at the intersection of that origin. Okay, so the tail starts at the origin for B. Then our next vector is we're going to add C to B. So I'm going to move C. Its tail is going to go to the tip of B. And I can see I need to move my A. I'm going to, oopsie, move, scooch it up here a little bit. Okay. And then you're going to notice that after C, I'm going to add A. So what I'm going to do here is I'm going to move A, and I'm going to grab a point because I don't know if it's going to point left or point right. I'm going to go nearest right around here, and I'm going to put it on the end of C. I'm going to be looking for an intersection once I complete my other side, okay? So that exhausts everything on the left-hand side of my equal sign. B plus C, and then A is at the end point right now of C, or at the tip of C, waiting to find out which way it's going to go, okay? Now we're going to work on the right-hand side of our equation. On the right-hand side, since we're crossing the equal sign, the first vector D is going to be moved so that its tail is at the origin, okay? So B is pushing away from the origin, and so is D, okay? After I have D in place, then on the tip of D, I'm going to put vector E. So I'm going to move E, and I'll do that same thing. And I'm going to go nearest, and I'm going to put it on the tip of D. I'm going to move my E to the opposite side here. There we go. Now, what we have, I'm going to move my equation down. What we have here is we have the positions of each one of these. We've exhausted both sides of placing the vectors on either side of the equal sign. And now what I need to find is the intersection that is going to give me the endpoints for A and E. And you can see that it's going to be up here. You see that? So what I'm going to do is I'm going to select A, and I'm just going to pull horizontally, make sure that you don't, go at an angle. And then I'm going to do an extend underneath trim on E. And then I can trim away the extras beyond the endpoints there, okay? So everybody see what I did? Where we found the intersections of A and E, okay? Now, arrowheads. We need to add the arrowheads to give direction. So we could measure right now and get magnitude, but we know the direction is along a horizontal line for A, and it's along a vertical line for E. But which way are we going to point our arrowheads? Okay. So we're going to look at our equation. We have on the left-hand side, B plus C, tip to tail. And now we're going to add A. So that means that the tail of A is going to be at the tip of C. And that means that the tip of A is then going to be pointing to the right. So we are going to put the tip of A here and here. So it's B plus C plus A. Okay. We'll do the dimension in just a bit. Let's put the arrowhead on E. E, you'll notice, is added to D. So we've got D, the tip of D, we're going to have the tail of E. And now that means that the arrowhead for E is going to be pointing up, right? Questions on that? So here we have D plus E. So when we look here, you'll notice that the two arrowheads, A and E, are meeting at the very same point. And that makes sense because we need our left-hand side to be equal to our right-hand side. So they're going to meet at that same point up there. You cannot have your arrowheads going in a circle, remember, okay? We're not going in a circle, we're equaling. We want to end up at the same point on both sides. Okay? All right, so then the last part of this is going to be determining those magnitudes by adding in our dimensions. So I'm going to go to the notes, and I'm going to go over to the annotate tab, and I am going to be putting in a linear dimension for each of these just because they are linear. Make sure you grab endpoints. The dimension is too small, so I have to arrow down, modify, go to the Fit tab, and change your scale to, I'm going to say 40, I think is what I used in my first class, but it just all depends. Oh, I don't have my numbers key on, sorry. Okay, set as current. We'll see how that looks. Not awesome. I need it bigger. Modify. I'm going to go back to the Fit tab. I'm going to say 60. Hopefully that'll be okay. And then close. Yeah, that's pretty good. I just want to ensure that when I do my screenshot, that I can see it on my paper. Okay, that's what the big deal is. Okay, so I got 303.9, and then I'm going to do another linear dimension here. And I get 161.6. Okay, so I'll kind of put these two here. So E is 304 and A is 161. Now, if we look at the answers in our book, they aren't the same, and they're actually off significantly. So, for instance, we are at the top of page 64. They have 160 for A and 306 for E. These are not correct. I mean, they're close-ish, but not close enough. The answers you need to get are going to be, and I'm certain on this, it's going to be 303.9 for E and 161.6 for A. Okay? All right. So now make sure for this example that you have the equation, okay? B plus C plus A is equal to D plus E. That you have each one of your vectors identified, and then for A and E, that you have the dimensions seeable, large enough so I can see them, and then you can take your screenshot and add it to your Module 2 practice problems. Okay? Any questions on this one? Okay, so I will stop our recording here.